Alright, y'all, it's time to do our position versus time graphs, day 3. So y'all did a really good job on figuring out what position versus time graphs look like and what they mean, but now we're going to use them to figure out speed. So speed limit, ain't nobody got time for that. First off, shout out to the 100 percenters in UConn. This was Justin Hicks, Kentrell Millette, Kalia Pearson, and Alavria Thayer. In Alcorn, this was Paris, Robert, Antoine, Crystal, Isaiah, Talia, Tanel, and Teriel. And in Richmond, this was Amy, Niall, Zaitia, Jalen, Kanijah, Michelle, Ryan, Anner, Kanisha, Brianna, Amaya, David, Raphael, Elsie, Jai, Kayla, and Kanisha. So this is what we are doing today. Our essential question is, how do we measure speed? Our objective is we will determine speed from distance versus time graphs, and our homework is to finish the packet. Note number 1, speed is measured by taking a distance divided by a time. So if I have 30 and I divide it by my time, which is 3. So I know that 30 divided by 3 is going to be 10 meters per second. Note number 2, objects traveling at the same speed will have the same slope. So I know that these two lines are traveling at the same speed because one line, they're covering the same distance over time. One line is just starting 10 meters in front of the other. So they're both covering the same distance in 4 seconds. One line is just starting at 10 meters while the other is starting at 20 meters. Note number 3, a faster object will have a steeper slope than a slower object. I know my green line is going to be fastest because it covered 4 meters in only 1 second. This is the fastest line. And my red line is going to be the slowest because it only covered about 1 meter and it took it 4 seconds. Note number 4, to find the speed of objects in this graph, if I have multiple lines, you're going to need to calculate all 3 speeds. So the speed of object A, I would take my distance, which is 4, and divide it by my time, which is 1. For the speed of my object B, I still have a distance of 4, but its time is now 3, so I would do 4 divided by 3. And the speed of object C, I know its distance is still 4, but this one took 5. So its distance is 4 and its time is 5. I would have to do that division problem. Note number 5, an intersection point means that there is one person passing another on the graph. So if I take a look at James and John, I know that James started further away from John and he's traveling slower. And John is traveling faster because his line is steeper. He's gaining more distance in less time. And point A is where John passed James because he's going faster.